Today we're going to be talking about the Pythagorean theorem and its converse. Just a reminder that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Remember that the hypotenuse is the side across from the right angle. The other two are the legs, and those are attached to the right angle. One thing I do want to note here, and we're going to be looking at this a lot during this unit, you'll notice that the angles are labeled with capital letters A, B, and C, and then the sides across from them are labeled with the lowercase version. So across from angle A is side little a, or lowercase a. Across from angle B is side lowercase b. Across from angle C, the hypotenuse is lowercase c. All right, so this is pretty consistent with how we're going to be naming sides, especially when we get to the right triangle trig portion of this unit. So just know that across from the angle, that side takes the lowercase version of that letter as its name. All right, so this would still work with our a squared plus b squared equals c squared. All right, so that c is the hypotenuse, the a and the b are our legs. All right, so we're going to solve using the Pythagorean theorem. So the first thing you want to establish is, are you solving for a leg or the hypotenuse? So in this first problem, I see that I'm solving for the hypotenuse because that's directly across from that right angle. So with my legs, it doesn't matter which side I'm plugging in for A or B, as long as I have both of my legs on that same side. So I have 4 squared plus 7 squared equals x squared, or c squared. All right, 4 squared is 16, plus 7 squared is 49, still equals x squared. Then we're going to add 16 plus 49 together, we get 65 equals x squared. Now remember, to undo a square, you're going to take the square root of both sides. So I get x equals the square root of 65. And when I take the square root of 65, I get 8.06, which rounded to the nearest tenth will give me 8.1. All right, now in this next problem, we're solving for a leg. So I see that I have the hypotenuse, but I'm solving for one of my legs. I have the other leg. So I'm going to set this up as x squared plus 8 squared equals 12 squared. Now it doesn't matter again if I put the 8 squared or the x squared first, as long as they're both on that left side, or both on the same side with each other because they're both legs. So I have x squared plus 64 equals 144. Now I'm going to subtract the 64 from both sides. I'm going to end up with x squared equals 80. And again, I'm going to take the square root of that. So I get x equals 8.9, rounded to the nearest tenth. All right, so that's the quick review on solving using the Pythagorean theorem. So remember, it does make a difference where you put things, if it's a hypotenuse or if it's a leg in our triangle. Now this next piece is just something I want you to be aware of. We have something called a Pythagorean triple, and it's a set of 3 whole numbers that work with the Pythagorean theorem. So any of these in this chart, and there's more for you to fill in, but for example, 3, 4, 5. If I have a right triangle, the legs 3 and 4, and a hypotenuse of 5 would work with the Pythagorean theorem. So I'm going to show you 3 squared plus 4 squared equals 5 squared. 3 squared is 9 plus 4 squared is 16 equals 25. And then we have 25 equals 25. So this shows that with legs of 3 and 4 and a hypotenuse of 5, this would be a right triangle. You could say the same thing for any of these combinations here and their multiples. So if you took each of these numbers and multiplied them by 2, by 3, by 4. We don't always have to have Pythagorean triples. We could have numbers that have decimals in them, and often we will see that, especially when we get to real-world problems. So just know that Pythagorean triples are a thing. All it means is that all of our sides in our right triangle are whole numbers. All right, so let's just use the Pythagorean theorem to solve this problem. So we would have x squared plus 24 squared equals 26 squared. So again, we're left with x squared plus 576 equals 676. I'm going to subtract my 576 from both sides. That'll leave me with x squared equals 100. I'm going to take the square root. I get x equals 10. So that would be my leg here. Now, you see that this is a Pythagorean triple, the 10, 24, 26. If you look back at the chart that we were just looking at, these are multiples of the Pythagorean triple 5, 12, 13. So if you multiply each of these by 2, you'd get 10, 24, 26. All right, so if you knew the Pythagorean triples off the top of your head, which I'm not expecting you to do, not expecting you to memorize, you would know right away that that would have been 10. So the Pythagorean theorem will always work, though. I just, again, want you to be aware that Pythagorean triples are in existence, and it just means that we have whole numbers for each of our values of our sides. All right, so now we're going to start to put some real-world application here. Drawing pictures is going to be really important when we're doing this. They don't need to be pretty, but they need to be drawn so that you can see where things are in your triangle. So we have a 20-foot ladder placed against a building to reach a window that is 16 feet above the ground. So here's my building. Here's my window. All right, my ladder is not standing straight up. Remember that if you put a ladder up somewhere, it's going to have some slant to it. So this is my 20-foot ladder here. My window is 16 feet off the ground. And we want to know how many feet away the ladder is from the building. So that's going to be our x. All right, so we have a right triangle here. So we're solving for a leg. So I have x squared plus 16 squared equals 20 squared. That's my hypotenuse. So I have x squared plus 16 squared is 256 equals 20 squared, which is 400. So I'm going to subtract the 256 from both sides. And x squared equals 144. And again, I'm going to take my square root of both sides. So I get x equals 12. And that would be answer C. So this is an example of something you might see on a standardized test like your SATs. All right, and the last piece of this lesson that we're going to talk about is called the converse of the Pythagorean theorem. So what this is we're going to be given 3 sides of a potential triangle. The first thing you're going to do is test to see if it is, in fact, 3 values that could make a valid triangle. And then you're going to decide what kind of triangle it is given these inequality theorems. So basically, what we're boiling this down to, if the 3 sides work in the Pythagorean theorem, then it's a right triangle. Now, when you take the 2 smaller sides, because remember, the hypotenuse is always going to be the biggest side. It's always across from that 90-degree angle, which is the biggest angle in that triangle. So when you take the 2 smaller sides and you square them, add them together, if the biggest side is less than that, then we have an acute triangle. If you do the same thing and the biggest side squared is bigger than a squared plus b squared, then we have an obtuse triangle. So kind of think of it this way. If you have the biggest side being smaller than the other two ones, we'll do all the squaring. Smaller, acute has smaller angles, smaller than 90. If your c squared is bigger than the a squared plus b squared, it's bigger, it's obtuse. It's a bigger angle, bigger triangle, obtuse. All right, so let's go through what we would do to test to see if we have valid sides of a triangle. And then if we do, we're going to look at it and see what kind of triangle we have. Now to test if we have a triangle, we're first going to look at the sides. We want to look at the two smaller sides. Now, when we add those together, so 9 plus 12, we're not squaring anything just yet. We're just testing to see if it is a triangle. If that is bigger than the third side, then we have sides of a triangle. So 9 plus 12 is going to give us 21, and that is bigger than 15. So yes, we do have a triangle. So now what we're going to do is we're going to test what kind of triangle we have. Now we're going to use those triangle inequalities theorems that we were talking about earlier. So I'm going to just flip this around so it looks like the same format that we were talking about on that last page. So I have 15 squared, my biggest side squared, and we want to see what the relationship is between taking the two other sides, the smaller sides, squaring those and adding them together. All right, so 15 squared is going to give us 225. And then I have 9 squared is 81, plus 12 squared is 144. Now when I add the 81 and the 144 together, I'm going to get 225. I'm going to carry down this 225 over here. Now what I see is that both sides of this little inequality are equal to each other. So since they're equal to each other, if you look back at the chart we had on the last page, that means that this is a right triangle. So when c squared is equal to a squared plus b squared, that's a right triangle. All right, and while we're at it, I'm just going to write down the other two possibilities. So c squared being less than a squared plus b squared is acute. And c squared being greater than a squared plus b squared is obtuse. All right, so remember the first thing we want to do is just check to see if we do have a triangle here. All right, so let's test these sides. All right, so we want to take the two smaller sides, add them together, and make sure that that's bigger than the third side. So 10 plus 11 will again give us 21, and that's greater than 13. So yes, we do have a triangle. If we didn't have a triangle, we would just stop there. There's nothing more you could do. You can't test for what sides of a triangle you have if you don't have a triangle. So now we're going to do the same thing. We're going to take, and I'm going to again flip it around just so it fits the format of these formulas down here. So I'm going to take my biggest side squared, so 13 squared, and then I'm going to leave some space, and I have 10 squared plus 11 squared. All right, now again, this space is where we're going to put whatever sign needs to go in the middle. All right, so I have 13 squared, which is going to give me 169. 10 squared is 100, and 11 squared is 121. So I'm going to carry down this 169, and then I'm going to add 100 plus 121 is 221. Now I see that 221 is bigger than the 169. So since our c squared is smaller than our a squared plus our b squared, this means we have an acute triangle. So just in summary, first thing you do is test for a triangle. And to do that, you take your two smaller sides and you add them together, and you want it to be bigger than the third side or the biggest side. And if that's true, then you have a triangle. Then next you test for the kind of triangle. And you're going to use those inequality theorems that we talked about, and they're again right below here.